Hi, I'm Eric Brewer, and I'm happy to speak to you virtually today about the lessons from Kubernetes, which are lessons I hope will be useful to the Ray community. So my bigger goal in general is to make it possible to build cloud-native applications. And we're in the middle of this transition. It's about 5 years in. I would say it starts with things like the view that there's infinite resources in the cloud, and you can get them quickly and as many as you like. We tend to think about services and not machines. We tend to think about APIs and co-design and how we want our services to work together. And finally, we expect that we'll have high availability for everything we depend on and everything we offer. So that's our goal. How do we build those kinds of applications? And the good news is Google's been doing this in a while for at least 15 years, at least the use of containers. And coming up with Docker and its revolution, we kind of saw an opportunity to say, Docker is kind of like what we do. We were using containers internally mostly to simplify application management, but also for performance isolation, so we could run many applications on the same machine. Docker has a packaging format that makes that easier, so our use of Linux containers, their use of packaging worked well together, and that really led to Kubernetes. And what I want out of Kubernetes is this higher level of abstraction. So in Kubernetes, you should be thinking about things like, how do my services fit together? Things like load balancing should be kind of built in, right? Every service has load balancing needs. The names of services should be something that are a first-class thing compared to, say, IP addresses or DNS addresses. We should be able to help with state management and with monitoring and logging. And most of all, we should be able to help with upgrading, because the goal here, again, is high availability. How do we get our services to be both high velocity, meaning lots of feature changes, but also highly available even while they're being upgraded? Conversely, if we do this right, things you don't have to think about are the details of the operating system. You don't have to worry about packages or DLL conflicts, right? Those cause much problems when you're trying to run multiple applications on the same machine. In fact, the machine itself you shouldn't have to carry too much about. We really would like to have an abstract machine with whatever number of CPUs you happen to need. In fact, if you look at modern GKE, it has a whole way to automatically provision nodes on your behalf. Another big one is different languages, right? Everyone has their favorite language, and they have different favorite languages for different aspects. So ideally, every team should be able to use whatever languages they want and have it all work together in the service infrastructure. And even little things that cause us lots of trouble internally were fixed in Kubernetes. My favorite is port conflicts. When you have multiple applications on the same machine, which one gets port 80, for example? And the answer in Kubernetes is every pod has its own set of IP addresses and ports, and therefore the problem goes away. That's the high level abstraction we should be after. But what we're really after is one more step, which is velocity. And how I think about that is it's evolution, and we do this because we have abstract services. So ideally, the service is itself actually just a name, right, for an API. And the implementation of that API varies over time. Those are the versions. And Kubernetes is version aware and service aware, so it can route to the right versions. It can actually help with other kinds of things like canary testing or blue-gold deployments, things where you do special rollouts. That's really an important part of the infrastructure. The other way to think about this is the kind of the team view, that when you're using many services as the structure for your application, it means that you can mix the languages, but you also mix the teams. So when I look at what kinds of projects are high velocity, it's really when different teams can deploy independently, right? Independent upgrade and mixture of teams, mixture of language. That's what gives you both high availability and high velocity. So an important lesson, really the first and obvious lesson, most obvious lesson for Kubernetes is the value of open source. And it's worth pointing out that Kubernetes didn't have to be open source. That was actually a somewhat difficult decision for Google to make. And in the end, we made it for a few different reasons that are worth covering. First, Kubernetes is too big a change, right? We would like to make a massive change in how applications are built. Even Google, despite its size, is not big enough to make that change on its own, right? You need a lot of buy-in, not only from all the cloud players, but really from all the enterprises and from all the infrastructure that supports these systems. So that was the first big reason. That led us to create the CNCF, Cloud Native Computing Foundation, which is actually now more than 5 years old. In fact, I gave the original Kubernetes talk in 2014 at DockerCon. And so it was within that first year, we actually created this foundation. And that really is the place to house not only Kubernetes, but all of the ecosystem, which I'll get to in a minute. A second reason for open source is a little more subtle, but I think actually the main compelling one to me, which is that traditionally the way you would standardize something is you'd write a specification down. And that works well for things like airplanes or parts that don't change much. So if you look at a traditional ISO standard, for example, it's a written down thing that you all agree on, but that process takes years. Conversely, Kubernetes changes every quarter in a material way. And a normal specification-based process wouldn't work for that. So really, the goal here is that the code is in fact the de facto standard, and we need to make that work. And that use of the code as the standard means we get high velocity as well. The third big value of open source, which I think is a classic one, is kind of the broad customized use. Right? Google's not going to build Kubernetes by itself the way that everyone wants to consume it. And you saw this originally on extensive use of Kubernetes on-prem, right? Not even in the cloud. And then that in turn enabled hybrid and multi-cloud versions, and that's a giant industry now. But also much smaller versions like telco edges and even Raspberry Pis. So this broad use where it's customized for the environment, that's also part of open source. It's made the reach of Kubernetes much larger than it would have been otherwise. Second lesson from Kubernetes that I think is a pretty fundamental one to think about how to copy is what I call the innovation tree. And you can think of the tree as starting as a sapling with a trunk. And in the early days of Kubernetes, this would be 2014, or even the work before it was public in 2013, this is all about the trunk, right? It's what are the core things like the API framework, what is a pod, how does networking work? All that stuff was kind of in the core and had to get done right first. But that soon led to other efforts like networking storage that you can think of as the major trunks of Kubernetes tree, the major branches, sorry. And so this led to a SIG structure, special interest group, and now there are more than 10 special interest groups that actually specialize in different parts of Kubernetes or really different parts of cloud native. And this allows those groups to work in parallel. And I think that's really the big point here, is that this structure has given us parallel innovation. All the innovation is actually the leaves. And in fact, the core is actually quite stable now, and that's good because we need to depend on it. And in part, Kubernetes made another change that made this a bit better than it might have been otherwise, which is the way APIs work, particularly the custom resource definition, the Kubernetes resource model. Those allow extensions in a way that are consistent with the platform. And so really those two things, enabling specialization and lots of leaves and enabling a way to do customization, that's led to a tremendous amount of innovation across thousands and thousands of people. And if you take that one step farther, you realize that the success is actually not just the project, it's a whole ecosystem, right? The parallel innovation turns into parallel projects and parallel systems. And in fact, CNCF actually formalizes this now by having 3 levels of project maturity. And you can think of CNCF projects as actually innovation subtrees for some part of the larger cloud native space. So they started as sandbox projects, as it could be good ideas, but small teams working on them. Then to kind of incubating where they're approved and are going the right direction, to graduated, something like Kubernetes or Istio. And this has gone on long enough now that even Istio is itself a graduated project that's 4 years old. And in fact, there's another part of this ecosystem, which is the startups that were created. So there's hundreds of startups in this space. They're part of the ecosystem as well. And in fact, many existing companies pivoted. The most obvious example probably would be IBM with its acquisition of Red Hat. That's a giant bet on Kubernetes for the multi-cloud space. This crazy picture is the landscape of the Cloud Native Foundation. I don't expect you to actually see all these things, but the point is the ecosystem itself now is such a giant tree that you can't fit it on one page. And they actually have a whole other page which is the trail map, which kind of says how to work your way through this crazy picture. But this is really the sign of success of an ecosystem. It's giant and healthy. But the most important lesson I've left for last. And in Kubernetes, we call this chop wood and carry water. And the idea is that a lot of the important work you need to do for a successful long-term project is mundane, right? The virtue of the mundane. And there's obvious things here like bug fixes and security patches. A big one that I worry about is breaking changes in dependencies. There's thousands of dependencies in Kubernetes. When some of them change, Kubernetes has to change too. That's a lot of work and it isn't fun. It's the definition of mundane in my mind. Then other things that might be fun, might not, depends on the person. This is room for all kinds of contributors here: documentation, ease of use, UX, all kinds of things, right? But what you need to have a healthy community is that work is spread out widely and is effectively done by however many mechanisms you can use. The title, Chop Wood, Carry Water, is also the name of a CNCF award that we give for people that exemplify this virtue. And you get lots of things from that besides a healthy project, but you also get the fact that, Kubernetes is critical to all kinds of things now, not only digital native services, but now enterprises as well, and major banks are betting on Kubernetes. And I can imagine large parts of the infrastructure of the future betting on Kubernetes. This stuff has to work, and it has to be stable. And yet it also is undergoing a high rate of change. And the only way to do that is lots and lots of mundane work. One of my favorite kinds of mundane work is enabling testing. And people have always said, oh, you need test cases. But I think it's an extra level of importance now that is worth repeating. And the reason for this is you can't really have high velocity if you don't have test cases. Because you want other people to make good changes to your system. And when they do, they need to know if their changes will break stuff. And the only way they can know that is if you have test cases. And so an important kind of mundane work is test cases that are good enough to detect breaking changes. This also, by the way, is how we do the de facto standardization through conformance testing. Conformance tests are essentially, here's what we think the standard is, and here's how to tell if you're meeting it. And if you make a change that breaks the conformance test, you're not conforming. That is an important part of this kind of standardization, the kind based on code, that I think is critical for both open source and for high velocity. So to wrap up, Kubernetes has been a tremendous journey for me personally and for Google. The vision is pretty simple. We're building a new kind of cloud that runs at a higher level of abstraction, not machines and disks, but actually services and APIs. And yet we want it to run all the things. So Kubernetes in particular is a platform for all the platforms. It's also worth pointing out at this point that Kubernetes won. I think there's no debate that it is the platform for modern development. And that's why I hope Ray will be viewed as something built on top of Kubernetes as the default way to build and use it, so that you get the portability and the open source and the de facto standardization and all the things that come with it. The lessons: open source is the key part of this. Parallel innovation is the way to have a giant system with giant success, and you have to do the mundane stuff too. Thank you.